Hello friends, I welcome you in lecture number 19 on vector calculus. In lecture number 18, we have discussed about tangential form of Green's theorem, and in this lecture we are going to discuss about another form of Green's theorem which is known as normal form of Green's theorem. So before going for normal form, we just recall the tangential form of Green's theorem. So suppose I have a vector field f bar in two-dimensional plane, and suppose its components are capital M and capital N, and suppose this curve C is the boundary of some region R, or we can say that C is a simple closed smooth curve which encloses a region R in the xy plane. Then we know that if we are interested in the circulation of a vector field f bar which is given by m dx plus n dy, circulation of a vector field f bar along a curve C is given by double integral of circulation density which is equal to del n by del x minus del m by del y, and this double integral is evaluated along this region R which is enclosed by given closed curve C. This is tangential form of Green's theorem, and now we are going to discuss about normal form of Green's theorem. So what is difference between these two forms? So the difference is only in terms of physical interpretation. Otherwise line integral will be same, either we are using normal form of Green's theorem or tangential form of Green's theorem. This is tangential or circulation curl form of Green's theorem, and now we are going to discuss about normal form. So whenever you are asked to find out circulation of a given vector field, you have to use tangential form of Green's theorem. And whenever you are asked to find out flux of a vector field or outward flux of a vector field, then you have to use normal form of Green's theorem, which we are going to discuss in this session. So normal form of Green's theorem is used whenever in our question they ask us to find out the outward flux of a given vector field f bar, and if they ask to find out circulation of a given vector field, then we will use tangential form of Green's theorem. And if we are asked to find out simply line integral of a given vector field and nothing is specified, that either find circulation or flux, then we can use either tangential or normal form. That is our choice, but we will mostly use tangential form of Green's theorem if it is not specified about these physical terms, that is find circulation or find outward flux. And we have discussed in the previous lecture that this m dx plus n dy is known as circulation curl, and if we consider this quantity m dy minus n dx, and if we integrate this along a closed curve C which encloses this region R, then this line integral will give me the value of outward flux of a vector field f bar whose components are capital M and capital N, and this is also given by double integral, but instead of this del n by del x minus del m by del y, here we will write down divergence of given vector field f bar. We are familiar with the divergence of a vector field. So if I want to find out divergence of f bar equal to mi plus nj, then this is equal to partial derivative of first component with respect to x plus partial derivative of second component with respect to y. So here we are writing divergence of given vector field f bar del m by del x plus del n by del y double integral with respect to dA, that is either dx dy or dy dx. That will be clear from the given problem, that we have to decide which form we have to use, either dx dy or dy dx. Okay, fine. So we will remember both of these forms of Green's theorem. First one is circulation or tangential form of Green's theorem. Second one is normal form of Green's theorem. We will use this tangential form of Green's theorem whenever in the question they ask us to find out the circulation of a vector field f bar, and if they ask to find out the outward flux of a vector field f bar, we will use normal form of the Green's theorem. For circulation form, we will consider m dx plus n dy, and here we will consider del n by del x minus del m by del y. For outward flux or for normal form, we will remember this m dy minus n dx, and this is equal to divergence of given vector field f bar. So remember these two forms of Green's theorem. Sometimes they ask you to find out outward flux of a vector field f bar. In that case you have to use normal form of Green's theorem, and sometimes they ask you to find out circulation of a vector field f bar. In that case you have to use tangential form of Green's theorem. And if they ask you to obtain the value of line integral and they don't specify any physical terms like circulation or flux, then you can use either normal form or tangential form. But generally all the references are using this tangential form if nothing is specified about the physical terms related to this. So we will also use this tangential form to obtain the line integral of a vector field f bar. But remember again that if they ask you to find out circulation of a vector field f bar, then use tangential form, and if they ask you to find out the outward flux of a given vector field f bar, then use normal form of Green's theorem. Tangential form is also known as circulation curl form of a Green's theorem, and normal form is also known as divergence form of a Green's theorem. So remember this statement also. Green's theorem in normal form, or another word is flux divergence form. Sometimes they can ask you to write down the statement of Green's theorem in normal form, then you have to write systematically in this way. Let C be a positively oriented, piecewise smooth, simple closed curve, and let R be the region enclosed by the curve C. And suppose our f bar, vector field f bar, has two components, m and n, that is our vector field f bar is mi plus nj, and if these two components have continuous partial derivatives of first order on region R, then the outward flux of a field f bar across a curve C, that is this quantity on the left hand side. This quantity is nothing but the outward flux of a field f bar across or along curve C. So this quantity on the left hand side is outward flux of a vector field f bar, which is equal to mi plus nj, and this is m dy minus n dx, and this is equal to double integral of divergence of this f bar, which is del m by del x plus del n by del y over the region R. So this quantity is nothing but divergence of f bar. So this is the reason that for another name for normal form is flux divergence form, because here we are using flux and divergence. And similarly another name for tangential form is circulation curl form, because here we are using, this is left hand side is circulation of a vector field, and here this quantity del n by del x, this quantity del n by del x minus del m by del y is nothing but curl of a vector field f bar. So now I believe that you have understood about both the forms of Green's theorem, tangential form and normal form, and from upcoming lecture we will discuss problems related to Green's theorem. So I stop here. Thanks for watching.